This video is the third video in the chemical solutions set of videos for Leaving Certificate Chemistry. In this video, we're going to be focusing on section 2, which is the units of concentration, and in particular, we're going to be looking at parts per million. If we're looking at the learning intentions that we're going to focus on in this particular video, we're going to look at expressing the concentration of a solution in parts per million. As I mentioned in the last video, the concentration of a solution can be expressed in several ways. Firstly, it can be expressed in percentage concentration, which we looked at in the last video. In this video, we're going to be looking at parts per million, or which can be abbreviated to ppm. And in the next video, we're going to be looking at molarity, which is moles per litre. Before we start looking at calculations that involve expressing a solution's concentration in parts per million, we need to understand what parts per million actually is. As I've said previously, parts per million can be abbreviated to ppm, and ppm is just milligrams per litre. So 1 ppm is 1 milligrams per litre. So it's one part, for example, 1 milligram per million, and the million would be a litre. ppm is used to measure extremely dilute solutions, typically representing a concentration of 1 milligram of solute per litre of solution. It's commonly applied in water analysis. We'll be dealing with water analysis an awful lot in Leaving Certificate Chemistry. And, for example, the concentration of fluorine in drinking water is approximately 1 ppm, so 1 milligram of a fluorine-containing compound will be found in 1 litre of water. Where you'll most likely see ppm is when you're doing titrations in relation to water. And the reason why we express a concentration in ppm is because when it's expressed in grams per litre or even moles per litre, whatever it might be, the values are quite small. So when it's expressed in ppm, it's much easier to read. The calculations are quite simple, and they usually involve a few different types of questions. So for the remainder of this video, we'll be going through a few examples where you're asked to express the concentration of a solution in ppm. In example 2.7, it says convert 0.75 grams per litre to ppm. The first thing I do anytime I see a question like this is I write down what ppm stands for. And ppm is just parts per million, which is milligrams per litre. What we need to do is change the concentration to milligrams and litres. Here we have 0.75 grams in 1 litre. Now we need to change here the grams into milligrams. We've already got litre here, but we don't have the milligrams, we have grams. Now it's important to note that there is 1,000 milligrams in 1 gram. Therefore, we need to multiply the 0.75 by 1,000, and that will tell us how many milligrams there are. When we multiply 0.75 by 1,000, we'll end up with 750 milligrams, and that will be in 1 litre. Therefore, because we've now got it expressed in milligrams and in litres, we can say that we have 750 parts per million, or this is 750 ppm. Example 2.8 says convert 0.0003 milligrams per 100 centimeters cubed to parts per million. Again, when I see ppm, I write down what it means. And ppm is parts per million or milligrams per litre. If we look at what we have 0.0003 milligrams in 100 centimeters cubed. What I need to do is I need to make sure that it's in milligrams and in litres. At the moment, I do have milligrams, but I don't have litres. I have centimeters cubed and I have 100 centimeters cubed. The only thing I need to do to make this milligrams per litre is change the centimeters cubed into litre. And to do that, because I have 100 centimeters cubed, I just need to multiply both sides by 10. When I multiply by 10, I'll end up with 0.003 milligrams in 1,000 centimeters cubed. 1,000 centimeters cubed is the same as a litre, so I'm going to write 0.003 milligrams in 1 litre. Because I have milligrams and litre, I can express it as 0.003 ppm. The last example we'll look at in this video is example 2.9. In 2.9, it says a chemist analyzes 100 centimeter cube sample of water and finds that it contains 0.05 grams of calcium carbonate. Calculate the concentration of calcium carbonate in parts per million. This is more like an exam type question that you might see on parts per million. Again, as it's ppm, I'm going to write down exactly what ppm means. ppm means parts per million or milligrams per litre. If you know that, this question becomes a little bit easier. Now, in this particular question, it says that there's 0.005 grams in 100 centimeters cubed. All I need to do is change the unit so that it's in milligrams per litre. In this case, I have milligrams and grams, so I need to change the mass, and I have litre and I have 100 centimeters cubed, so I have to change the volume too. To change the grams into milligrams, I'm going to multiply both sides by 1,000, as there is 1,000 milligrams in a gram. Multiplying by 1,000, I'll end up with 5 milligrams in 100 centimeters cubed. Checking what we have now, we need it to be in milligrams per litre. At the moment, I have milligrams per 100 centimeters cubed. So I'm getting closer to what I need it to be for it to be parts per million. The next thing I need to do is work with this 100 centimeters cubed. I need it to be in litres, and there is 1,000 centimeters cubed in a litre. So all I need to do is I need to multiply both sides by 10 to get it in 1,000 centimeters cubed. When I multiply it by 10, I'll have 50 milligrams in 1,000 centimeters cubed, which is the same as having 50 milligrams in 1 litre. And when I have 50 milligrams in 1 litre, I will have 50 ppm. Therefore, what the chemist has done, the concentration of the calcium carbonate is 50 ppm. After going through those 3 types of calculations and also knowing what ppm is, you should now be confident in expressing the concentration of a solution in parts per million. That brings us to the end of this video.